intro on this one is, for Ceva's theorem, you need to kind of know two terms that you probably already know. Concurrent just means the lines all cross each other. So concurrent means these lines are concurrent with each other at point P. Collinear means that in one dimension, they all are in a line ABC. So concurrent is the two-dimensional version of collinear, right? You can maybe even think of this in 3D, but we're not doing that here. But concurrent is what happens in Ceva's theorem. You have a triangle, and you just have lines coming out of vertices, going to the opposite side, and they intersect at the same place, which we call concurrently intersect. Then you're going to see what the relationship of these sides are going around. Okay, go for it. So there we go. That's Ceva's theorem, is if you take a length of a side like AB and take the components AZ over ZB, and then you do the next side. You do BC, and then you're going to do BX over XC. And then the last side, which would be CY over YA. Going around the entire triangle, if you take those ratios of sides going in that clockwise or counterclockwise, you could go either way. Just don't do a double back. Don't go this way and then this way, because that will have an effect on this one. Any idea of how it'll affect it? We're always going to go in the same direction, this to this, but if you were to reverse one, do you have any idea what that would do to this product? Stay tuned, you'll see for Menelaus, we'll see what effect that has. Okay, for the proof for this one, I like what they did with altitudes and areas, and I'm not going to go through this, but they did not similar triangles as much as they did equiangular and then relating those triangle areas to prove this. But you can see that for the proof of Ceva. I'm not going to go through it. But I am going to go through some examples here. Example 16, P divides AB into 2 to 1. Now be careful. Usually you can go by what the visual is. You know, AP is obviously 2 and PB is 1. And then for BC, it's going to be 3 to 7. Find the ratio of where R divides CA. So here we go. I'm going to start here at C. 7 is to 3 times, don't put equals, times 1 is to 2 times AR is to RC. See how I just kept going around? 7 is to 3, 1 is to 2, AR is to RC, and that should be equal to 1, since they are concurrent in their intersection. So solving for AR over RC is just going to be 7, 6. This is going to be 6 over 7. And so if we're relating this division of, I think they did RC to AR, that's just going to be 7 to 6. You okay with that? Too easy? Yeah, it's too easy. Now the converse of Ceva's theorem is actually quite helpful and brilliant, is how do we know if this intersects concurrently? Well, you can know is if you go around, take those ratios like we did before, and if that ratio equals 1, then you've got an intersection concurrently. Sound good? Let's do it. So let's see if this example here works that way. LMN is a triangle, X is on LM, and then you have the other sides broken down. they gave you these lengths of each section. Let's see if MZ, NX, and LZ are collinear. Actually, I think concurrent is the term that you want. I would say concurrent, not collinear. And so here we go. Start at N. 5 is to 2, as 4 is to 5, as 3 is to 6. We'll see what that equals. Now, what should it be equal to? Should be 1. So this cancels out. 2 and 2, 2, 6. So is it equal to 1? Yes, it is. So MZ, NX, and LY are concurrent. Taking a look at this, does this seem obvious? So if it works, they're concurrent. Did I go too fast on that? Let's take this one. This is a little more interesting. Use the converse of Ceva's theorem to prove that the medians of triangles are concurrent. So this is like x, x, y, y, z, z. And if you were to go x over x times y over y times z over z, what's that going to be equal to? What's that equal to? 1, right? So there it is. So therefore, AP, BQ, and CR are concurrent using converse of Ceva's theorem. So the key to this is picking a point, doesn't matter which one, and then just going in the same direction, ratio, 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 and then that should be equal to 1 in order to meet the expectations that they all intersect in the middle concurrently. Okay, well, let's go for it here. Try 1 and 2 and see what you are able to do. Do those. Actually, I'm going to have you do 1, 2, 4, 6, and the challenger. So 5 and 6. Do all of those, and we'll go over them in 10 minutes.